Okay, I've gone back to a non-shared window system. Okay, so now we are going back to the IAM application. If I go and move my cursor here, it's not as if you're seeing the change. Okay, and again we have delays. So if I type A here, I guess I got the windows a little wrong, but it doesn't matter. So Kathy's in the middle now. Okay, you saw Bob saw the character immediately, and Kathy's going to take a while to see the characters. Okay, so um, okay, finally Kathy sees it. So obviously, if they are discussing something, if they have an audio conversation going on, the delay is an issue, right? But let's say that Kathy's just observing things, okay, and entering, and maybe there's no audio. We saw with the shared window system, um, there was this jitter issue, and we were doing things, which we were doing a drag operation, and the drag operation was sensitive to the delays and jitter. Okay, there's no drag operation here. I'm just typing, and yes, there's a delay, but maybe we can live with delays. We're all used to delays. So can you imagine something really bad happening beyond just the delays, beyond just latency when you have delays, assuming peer-to-peer communication? Some inconsistency arising?
If Alice does something and then Bob does something and Kathy receives those events out of order, could that create inconsistency?
That could create inconsistency, right? So Bob goes and says the words, or Alice says that. Bob says are lovely. Kathy sees that. She says, "What about the woods?" You haven't recited the poem in the right order. Okay, and as it turns out, and the woods comes later. Okay? As it turns out, it's inserted the right position just because the way I send events. But the point is that Kathy made a wrong judgment about this. And has this ever happened to you in an IM conversation that it has? The very first time that I used IM, I was in Microsoft, and we were talking about, where to go for lunch, and whether somebody should come to my office or I should go to their office. And we both made different conclusions based on the order in which we saw things. And I ended up going to his office, and he ended up coming to my office. And so I've always wondered what causal IM. And that's just two people. And when you have end users, you have a bigger problem. Okay? And similarly, if I go and type B here and type C here, you'll see this more dramatically that it'll be C and B on Kathy's, probably it'll be C and B. Oh, actually, did something break right here? Something might have broken also for all. Oh, okay. I haven't tried this path through my demos before, so you never know. But I'm not sure why C got delayed. But let me just go and so how can we overcome this problem, you think? Something broke here, I think. Yeah, that's because I think the index came at a position that was not expecting at. So how can we fix this problem? Yeah.
Not use peer-to-peer.
Not use peer-to-peer. Okay. So we'll see that in the next demo that we won't use peer-to-peer. But sometimes you want to use peer-to-peer because if you don't use peer-to-peer, if everything goes to a central process, everybody sees things in the same order. Okay. Anything else we can do? Okay, we'll see whether this works or not because I might have crashed something. I'm going to do some magic. I'm going to say that we're going to support causality. Causality means that I don't see a message if the message that caused it hasn't arrived as yet. So if a message M arrives, which is caused by a message P, then I won't see message M till I've seen P. I'll somehow keep track of which message caused which. Okay, and I'll keep peer-to-peer. And we'll see if this works. So I say dark, and I say deep, and I think Kathy's just out of it right now. Oh, let's see. I made it causal, so it should just come in the right order. Yep, we came in the right order. Okay? It was delayed, but somehow the system knew enough that when Bob's message arrived, it said, Bob sent to Kathy not only his own message, but some succinct summary of what it had received earlier, hopefully not the list of all messages, which was enough information for Kathy to determine that something hasn't arrived earlier. And what could Bob send? Simple thing.
Basically, graph or linked list on most of the messages.
Or it could. What about just sending the real time?
Yeah. Assuming they all agree on the cost.
Big assumption. So we don't send the real time, we send a logical time, which is not a linked list, it's a little bit vector. It's got one number for each site, that's it. Okay? It's one of the neatest algorithms in distributed computing. Okay, so when I said this course is not about distributed computing, I was talking about distributed computing among two processes. Okay, that's sort of what I teach in distributed systems. When you have n processes, that's called group communication, okay, which is what collaboration is all about. And this is one of the neatest papers in group communication. Okay, so that's